we're going to go ahead and get started. Again, my name is John Midwell. I'm a Customer Service Manager here at Scalability Experts. Welcome to our webinar on cloud services and data management. Today we'll be discussing how you can leverage the latest in cloud technology to lower your total cost of ownership and make your databases more scalable and manageable. Before we get into the presentations, I'd like to take a minute to thank everyone involved from Scalability Experts and Microsoft who helped organize today's webinar. More specifically, I'd like to recognize and thank our two presenters that you'll be hearing from today. We're very lucky to have these two experts with us. Together, they combined for over 50 years of technical experience, and they are leaders in their fields. The first presenter today is Roger Wolter. He's a principal architect of Scalability Experts. He has 25 years of experience in system architecture, program management, and product development. The second presenter we'll be hearing from today is Buck Woody. He's a senior technical specialist with Microsoft, has 25 years of platform architecture experience. He's a popular speaker at TechEd, PASS, and other conferences, and he is also an author of over 500 articles and 5 books on databases. The presentations will last approximately 40 to 45 minutes, and we will have a live Q&A session at the end. So please post your questions using the question function at the top of your screen. If you have several questions, we do recommend that you fill all of them into Notepad and copy them in to prevent problems. The way the system works is you can only have one question open at a time. Also, if you have additional questions at the end of your session, you can also email our two presenters directly using the email addresses listed in this presentation slide. You'll have a taped replay of the webinar also available for viewing on our scalabilityexperts.com website in the next few days. Well, without further ado, I'm going to turn control of this presentation over to our first speaker, Roger Wolter. Roger?
Thanks, John. Here's a quick agenda of what we're going to talk about. Just the first few sections are just a general introduction to cloud computing and cloud databases in particular, and then the second half we'll turn most of this over to Buck, and he will talk to us about SQL Azure and how that implements cloud databases and what does that mean. So we'll start off with just basically what is a cloud. The simple definition I like to work with, it's a collection of computing resources that normally are accessible through a network. And the key here is that these resources are shared both flexibly and transparently by a number of different applications and in most cases a number of different users. So some of the characteristics of cloud computing is normally for when you have a cloud database or a cloud infrastructure, you pay for it by usage. You don't pay for infrastructure or capacity that you don't use. They're multi-tenant. The cloud service providers, make their money by having a set of servers that are shared by hundreds or thousands or even millions of different users. Self-provisioning. So you don't have to go to your IT department to get a new database when you need one for an application. You can just log on and create a database yourself, and it will be completely up and running for you in a very short period of time. And normally clouds use some sort of a virtualized environment to provide the kind of isolation that you need to make the multi-tenancy work. There's two kinds of clouds that people talk about in general. One is a public cloud. This is one when we first talk about cloud computing, this is what most people think of. This is, as the name implies, it's a public cloud that a bunch of different companies share. For example, it's provided by Microsoft or Amazon or one of the other cloud providers. And basically what you're doing is leasing space on that cloud, on their set of servers. There are different types of public clouds. A lot of the early public clouds were what I guess we call the infrastructure as a service, which is not very hugely different than a service bureau where you're actually basically are renting a virtual machine and you get to put your own OS, your own applications. Use it in whatever way you see fit, and basically they're just providing you a virtual machine that you can use. There's also platform as a service, where there's a set of platform services, for example, databases and messaging and web servers and those kinds of things. They're available to build your application on. And so you build a cloud application on top of a platform that is furnished by the cloud provider. One of the key examples of that is Microsoft Windows Azure, which is platform as a service. In this case, the infrastructure is managed by Microsoft. You aren't paying for any of those servers. You're actually paying for the amount of server that you use at any given time. And you're also paying for the amount of license that you use at any given time. You don't have to go through trying to anticipate your current and future usages. You only you can use what you need, and as your needs expand and contract, the amount of service that you use expands and contracts, which is basically what I mean by high elasticity there. Applications are very, very elastic in a cloud. So you can, for example, if you have a web application, you can add servers, take away servers, as the needs arise, as your loads change. Databases are a little bit less elastic in that, it's not enough to just say, I want another database running. You actually have to deal with how do you keep the data in sync and those kinds of things. So there's some extra considerations that you have to keep in mind when you're expanding on a database. The key to a public cloud is that you significantly reduce the management expenses of running an application. You just manage the application itself, or in the case of a database, you manage the database, but all the physical stuff, what does my SAN look like? How do I allocate space? How do I make sure that I've got enough processes available to do this thing? That's all done for you. Private cloud is, in essence, is using some of the same principles that a public cloud uses, but you're running it on a set of servers that are within your enterprise that you own. So you get some of the advantages of a public cloud, but you don't get the advantage of least capacity and all that kind of stuff. You're running it on your servers. So again, you're paying for those servers. You're paying maintenance on those servers. You're actually maintaining those servers, installing patches and all that kind of stuff. All the stuff that the public cloud vendor did for you are now things that you have to do. But some of the advantages like self-provisioning are still there. That allow your application owners to go in and provision a database, so they don't have to come to IT and get a database created for them. Virtualization is normally a key part of a private cloud. Private clouds are normally built on either VMware or Hyper-V as a basis for handing out the resources and dealing with them and provisioning them. And I guess the last point is that a private cloud is generally not a scaled-down public cloud. In other words, there's no such thing as an Azure cloud that you can buy and implement in your enterprise. I mean, it really doesn't make sense because of the scales involved in doing that. So let's talk about a public cloud database. The one that I'm going to talk a little bit about here and Buck is going to expand on later is SQL Azure. SQL Azure is important because it's one of the few cloud databases that's a fully featured relational database. You can run SQL against it. You can run almost all of the SQL commands that you can run against SQL Server, work against SQL Azure. There are a few commands that are difficult to run in the public cloud architecture just because of the way that databases are configured and for security reasons and those. So there are a couple things that don't run in SQL Azure. But for the most part, it pretty much acts like SQL Server. Again, it's self-provisioning. There's a lot of value in that in terms of not having to have your application owners deal with IT every time they need one. Usage-based pricing, as we talked about before, very, very highly available databases. All your data, SQL Azure automatically keeps 3 copies of your data on 3 different servers, so the high availability is built in. For scalability, currently There's a 50 gigabyte max size that's supposed to be going up to 150 gigabytes very shortly, and more growth is in sight. I don't, as time goes on, and the infrastructure in SQL Azure matures, I think that will continue to grow. You scale by adding databases for the most part, if whatever the maximum is there, and then there's also a federation that allows you a single application to talk to multiple databases that are partitioned. This is going to be built into Azure very shortly. This is already available in the CTP release, and it should be released in a few months here. One of the things you always get asked are, what kinds of things should I be running on SQL Azure? And this is just a very small list of things that are, number one, the things that are appropriate scenarios, and then number two are things that are maybe marginal, that maybe could run in SQL Azure, but probably are not the key scenarios. So anything that requires quick provisioning, for example, if you have people that are building prototypes, they're doing development that they want to actually just create a database and do some work on it and be able to get that going. The other one is sudden requirements. If when the boss comes down and says, I need a database to do this, I need it this afternoon, or I need it tomorrow morning. In a normal IT environment, that's very, very difficult to do. But in a SQL Azure environment, you can get a database up and running in a matter of minutes. So reduce risk in new projects. Instead of the first thing that you do in your project is order a whole bunch of servers and a whole bunch of disks for your SAN and find space in a data center to install this and all that kind of stuff. You can create a new project, run it completely on SQL Azure, and then see whether that's something that your customers like or that your users like. And if it works out, you may in fact move it internally later, or you may keep it running. But there's a very low risk in being able to create a new project doing this. Geographic availability. There are currently 6 data centers where you can have SQL Azure, so you can have an application that is geographically dispersed without actually managing data centers in remote locations yourself. And then Azure itself was designed to create dynamic web applications that use SQL Azure to give a lot of intelligence to an application and allow it to do, be very, very compelling and useful as an application that your users will be excited to use. So the marginal applications for SQL Azure, obviously if you're doing a multi-terabyte data warehouse, putting it out there, number one, putting out there 50 gigabytes at a time is going to be hard to manage. And probably the other thing is that this thing is on a network, and you have to move the data into your data warehouse on a network. So if you're going to be moving hundreds of gigabytes into a data warehouse a day, as a lot of people do, doing that all over a network to a remote location can get to be problematical. Compliance restricted applications. The public database, public cloud database providers have bent over backwards, done a huge amount of work in making their offerings as secure as possible, but there's still a lot of doubt out there, especially among compliance regulators and all that kind of stuff, in terms of saying, well, you're going to put your highly restricted, highly important data out on a set of servers that you don't own that are shared with a bunch of other users. That on the face of it seems a little bit risky. And so it'll be a while until I think that the cloud databases are well enough known and well enough, have enough of a reputation to allow, the compliance regulators to allow to put that kind of data out there. Third-party applications, you may or may not be able to actually run a third-party application because, as I said, the Azure is not 100%, even though it's close. SQL Azure is not 100% compatible with SQL Server, so you may have to get your third-party vendor to approve putting their application out on SQL Azure. And last one here is using a database in a cloud for a local OLTP application, the network overhead of doing all your SQL calls across a network to a remote data center can be pretty problematic. Private cloud databases are basically, as we said, a private cloud is located on premises. So in this case, you're normally going to be running your databases in a virtualized environment. You'll say, for example, you've got Hyper-V, where when somebody comes in and asks for a database, they will deploy a database instance either in a SQL instance that already exists in a Hyper-V virtual machine, or depending on the requirements, it may create a new Hyper-V virtual machine with a new instance to host your database. One of the keys to making this thing work is standard configurations. So instead of every application owner, when they come into IT, asking for a database that has a unique set of features that the application requires, a private cloud will offer a set of database configurations. Some of them may have full high availability disaster recovery. Some of them may be more suited for tests that have no high availability disaster recovery built in. Those kinds of things. And so you get to order the database that you want based on a limited choice. And then there'll be a kind of a Chinese menu thing that you go through that says, well, if I order this, then these are the options. And then if I choose these options, I might have some other options. But I can build up a database based on a set of standard configurations. So that makes it easier to manage and automate these databases instead of every database being different. You have a few standard configurations, so you could create standardized automation for each configuration and standardized management for each configuration that makes your management a lot easier to handle. Reduce support and training costs, because again, your support people only need to know how to manage a set of standard databases. They don't have to know how to manage every possible database that someone might consider doing. And again, virtualization is used to make provisioning much quicker and more flexible, and also to provide isolation. If you have applications that you need to run separately, either for security reasons or maybe because they're running on slightly different OS versions or different database versions, you can do that using virtualization fairly easily. And this one is just, I won't spend the time to go through this. There's a white paper that you'll be receiving after this webcast that goes through these in more detail. But the main thing I wanted to point out is there's a whole set of services. If you're going to implement a private cloud, it goes beyond just having virtualization. There's a set of services that you need to take into account. And again, in a public cloud, most of these services are provided for you. In a private cloud, you have to make sure that you've got taken these kinds of services into account when you create a private cloud. And here's just a real quick possible architecture of a private cloud for running SQL Server. So again, you have a Windows cluster. You have four Windows Server instances. Each one of those is running an instance of Hyper-V with a bunch of VMs. And each VM has up to has a SQL Server instance, again, which has up to 4 databases. These are all hooked together on a fiber channel SAN. Down in the right-hand corner, in this case, we're looking at System Center Essentials as a way to manage all these things. System Center Essentials does a very good job of managing Hyper-V and also managing SQL Server, so this is probably a very good thing to not only manage the operation, but implement the self-provisioning configuration systems that you need to do. And then Scalability Experts has a set of private cloud offerings that we can do to help you get this private cloud set up and to implement the scripting and all that kind of stuff that is required for doing that. So at this point, I'll turn this over to Buck, and he will talk about SQL Azure. Thanks a lot, and it's all yours, Buck.
Thanks, Roger. Hey, listen, guys, thanks. Appreciate your time and coming in to listen to us today. I'm Buck Woody. As I mentioned, or as they mentioned at the beginning of the session, I'm actually a technical specialist, so I'm not in marketing or anything like that. I actually work with our clients on real-world implementations of the SQL Azure platform, which is separate but works with the Windows Azure platform, which we're not talking about today. If you're interested in something like that, just let me know. It's buck.woody@microsoft.com. Also, I just want to point out as well, Roger and the folks on the Scalability Experts side will be managing the Q&A. So if you have a question as we're going, just click that little Q&A button and just type in your question there, and they'll interrupt me and just ask that. We may hold those to the end because I've got quite a few things I'll be going through here momentarily. And we'll be moving pretty quickly, but it's okay. At the very end, I'm going to have a link for you where you can go see all of the information I'm describing, talked about in more detail. And there are specialists in all of Microsoft that can assist you with that Windows Azure working with Scalability Experts. So let's get started. SQL Azure, as Roger mentioned, is basically SQL Server, currently version 2008 R2, and we'll talk about the versioning in a bit later. But basically, it's a version of SQL Server 2008 R2 that's just running somewhere else. And you will provision and use databases within that platform. So we'll talk a little bit about the logical architecture, in other words, how it looks to somebody designing the system or paying for it. And then we'll talk about the actual physical architecture a little. Those details change as time goes on, but I know there's probably a couple of technical folks on the call that would be interested to see how we do this. So let's talk about that a little bit further. Let's first talk about the logical architecture. We start out with something called a subscription. Basically what this means is you're going to log into a portal. You can do that with your Windows Live account or a Live ID that you use as a department. And there are the ability to basically have more than one manager if you wish. But at any rate, you're going to provision one or more servers. And although you can't see me, I'm doing air quotes. We'll talk about why that's true in just a moment. This is basically how you are going to be billed. You're billed by the size of your database and the number of databases. If you go out to windowsazure.com and then click on the billing side there's a nice little slider that'll just let you slide the document around, and you can see how much it would cost you to run a database in Azure of any size. As Roger mentioned, the current limit is about 50 gigabytes, but you can have obviously smaller increments than that. And we've announced support for up to 150 gigabytes, and again, just look for that to increase over time. Also be aware that we've announced the SQL Azure Federations, and we can talk about that at another time. But the idea there is it splits up the databases similar to what you do with table partitioning today. So once you've made your subscription, the next thing you set up is something called a server, and this is nothing more than a logical construct that will hold databases for you. Again, depending on how you use SQL Azure, which we'll discuss further in just a moment, you can have these containers that will allow you to keep things logically separated. We also do this for the geolocation. So we have worldwide data centers here in the U.S. or the Americas region. We have Asia and we have Europe. And we actually will balance across those, but we won't balance across regions. What that means is I won't take your American data and move it to Asia or vice versa. You're certainly allowed to do that, but we won't do that to you automatically for legal and other reasons. All right. So what this does is going to give you a long name. This is the server you would normally connect to in something like SQL Server Management Studio or BCP or SSIS, any of those kinds of tools, or even in C# or Java code. From there, you set up one or more databases. Now, you notice I've got 3 pictures of databases. What we do is whenever you create a database, we actually replicate it 2 more times for you. You don't get charged for that. That's our failover capability and the ability to keep you safe in the event of an issue. We do a 3-way commit, meaning that all particular mirrors are always kept in sync so that we can fail it over. We'll talk about why that becomes interesting in just a moment. but you should understand that this is sort of the level that you start out with, is the database itself. The other two constructs have more to do with billing than they do the technology itself. All right, let's take a look now at the sort of the physical internals, because this becomes something a little more important. We'll come back to this. So you saw the logical arrangement, or how it looks sort of to tools and so on, but here's what we're really doing. If you have an application of some sort, let's say Management Studio or your server-side code, and we'll talk about where that might live in a moment, but you've got code running somewhere that wants to talk to Azure, it's basically going to talk out through the standard tabular data stream or TDS layer that all SQL Server dialects use. So it's going to look to your application or anything else like a SQL Server database. There'll be no difference. Your Transact SQL runs just fine. The only thing you're going to find is a few features that are not there, which we'll talk about briefly. This goes out over TCP, and it must be encrypted. We don't allow unencrypted communications into SQL Azure. That's for your safety and for ours. Now, interestingly, even though you're typing in Transact SQL to what looks like a SQL Server to you, in fact, what you hit first is a load balancer. The load balancer makes sure that, number one, you're encrypted. Number two, that you are who you say you are. We have firewall rules that you can set up and so on. And it also makes sure that it's only TDS type traffic over TCP. So if someone's attempting to break in with some other protocol or some malformed packet request, it simply drops the packet and doesn't go any further than the load balancer. The load balancer is also what answers you and pulls back from there. So let's talk about what happens next. Actually, the load balancer has a full face to the internet, but then behind it, it has a full security barrier. And the request goes from the load balancer, still talking TDS, still acting like it's a SQL Server, but it actually goes in a round-robin fashion to various gateway systems that will tear apart the packet. This works very similar to something like the engine components of the parser and the algebraizer and so on. It tears apart the packet, and it happens to know which SQL instance your database lives on. At the bottom, it is a SQL Server somewhere. But remember, we keep multiple copies of your database running around. So what we do with that is there's something called a fabric. And this fabric knows which copy of the mirror is authoritative at the moment. As your system becomes busy, as the server needs maintenance and so on, we'll simply fail over your request to another mirrored instance, and your request just keeps on going, never having to have affinity to a particular SQL Server. That's done within our fabric, which reports up to the gateway, which reports up to the load balancer. Again, this is probably more technical than some of you care about, but others want to know how we're doing this. This is the rough diagram of how it works. Obviously, at the very bottom, we're doing quite a bit more, but we don't talk about that for obvious reasons. So these are the physical internals. So you've now seen how it looks to logical tools, and now you've seen how it works physically underneath. Let's take a look at some of the differences between the on-premise here on the left and SQL Azure here on the right. Number one, when you start out on-premise, you own all of the hardware. You own the instance. You can right-click and select more memory. You can set the collation levels and so on. You can also choose to integrate the security with the Windows domain where the instance lives. And you're able to run tools like SQL Profiler or SQL Trace. However, over on Azure, your control level is at your subscription. This is where you add and subtract databases. It's at the database level where you have full control. You're able to set the things you would normally set on a database. Also within SQL Azure, we only allow currently SQL Server authentication. Now, this doesn't pose much of a problem for most applications, because in many applications there's a front-end system that is handling a completely different kind of security and then passing back requests to the SQL Server. Same thing would be done here. You could use one control account that you would allow only the application through, or you could set up accounts for each individual user just like you would a classical SQL Server system. The next thing that's a little different is that in the physical data structure of an on-premise server, you're able to set where the files go. You're able to set the sizes, and as long as the hard drive can hold it, you can put it there on the physical SQL server that you have on hand. But in SQL Azure, there are size limits. As I mentioned, the current one is 50 gigabytes per database, but again, there's ways to get terabytes of data running in SQL Azure if you wanted to do that. There's ways of doing that right now. You do have a limited number of DDL objects. For instance, you're not able to set the file group that your particular table or index might be running on. That's for obvious reasons because we're controlling that for load balancing. You're depending on us for performance and scale in that case. You have a full set of features inside an on-premise system, but they change by edition. So for instance, Express doesn't have things that Standard has, and Standard doesn't have things that Enterprise or Data Center Edition has. On the other hand, inside SQL Azure, all the features are exactly the same. It's just a size restriction. Now, because we don't allow you to directly access the hardware, one of the things that goes away is anything to do with the CLR layer. So any of the CLR type things become a little bit more problematic. With one notable exception, we do have the spatial data type inside SQL Azure. I recently posted on my blog, and if you just go out to blogs.msdn.com, the standard Microsoft blogs location, so blogs.msdn.com/BuckWoody, all one word. If you go there, you'll find my post on a very interesting use case for spatial data inside SQL Azure, and it has to do with mobile devices. So now let's talk about where you would use this thing, because it doesn't act like this would make any sense for anyone to use. It would make way more sense for somebody to just use something on-premise. Why would you use this? And actually, there are some really good reasons. The first one is something we call a departmental app, and this is something that where multiple departments, but perhaps a smaller subset of people than the entire enterprise, might want to throw up an Access or a database or a light switch application that one of your power users has written, and so on. You'd like to share that data, but you don't want the department to have to manage a full SQL server. You don't want to license it. You don't want to put it under backup control, and so on. And also, if these departments are geographically separated, we've had cases where people did not want to VPN back and forth just to use the database. In this case, we changed all of their Access databases to be one single SQL Azure database and simply pointed the Access front end at the SQL Azure database, and that works just fine. It was about a 5-minute cutover, very, 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 very quick. So that worked out really well, and the nice thing is then the departments could pay for that, and there was no IT staff required and so on past the initial design and high availability and disaster recovery setups, making sure the security was handled and so on. Once IT designed that, they got out of the shadow IT business and were able to focus on more core issues. The next place we've seen is something similar to this, but a data hub. So we had two companies that needed to share data, and so they would FTP this data back and forth to each other so that they could work with it, sort of a his, hers, and ours data. And what we did with this was we actually set up a SQL Azure database that contained the common data that both of them needed to work with. And so what happened is they retained their individual databases. One of them happened to be Oracle. The other side was SQL Server. The connection string inside their program, it was a web-based program, was able to connect to both SQL Azure and, in one case, SQL Server, and on the other case, the Oracle system, and was able to query both at the same time, bring that back into a consolidated data set, and they were able to completely eliminate any data transfer. They literally worked on the live customer data together, the ones that they shared. So that was an interesting use case and very valuable to them. The next one was something we call a shared storage application, and this is something where perhaps you want a sub-slice of your data available out to the web for whatever reason. In one case that people wanted to roll off 2 weeks of their HADR, high availability and disaster recovery, to SQL Azure. Again, it wasn't their only HADR, but it was another layer that they used to make sure that they could continue working even in the case of a geographic disaster. They'd be able to take their laptop, change the connection string and continue working on fresh data by rolling the data out in a window, a 2-week window to SQL Azure. We've also seen the shared storage application to where the customers were allowed to enter data of their choosing on SQL Azure, and the internal application would go read the SQL Azure data directly so that the financial folks could pull down data from the customer database and so on. Finally, another application use case that was very interesting is just a pure web application. Interestingly, in this case, the person's web application was not on Windows Azure, but was inside a hosted provider, a standard ASP.NET page that they wanted a database for. And the particular service they were using, they didn't like the particular database that was offered, so they wanted to retain standard Transact SQL. And both systems, both Windows, or rather the application and SQL Azure, were on the web. They were able to access that and keep the whole thing out of their building. This was for a forward-facing web store, and they didn't have to bring anything or open any holes or host any SQL servers or pay any licensing or learn Postgres or MySQL or whatever else. They were able just to throw it out there. The nice thing, because of the costing model, they're now able to tie that back to how much it's worth for a customer to click on a certain link. So it's another use case that we see there. All right, this is what I wanted to get to, was the resources page here. And on this section, what I wanted to describe a little bit was this has everything you'd need to know, including a series of, I think it's 12 videos or 8 videos on SQL Azure, from writing applications through billing. I've got everything arranged there for you. Down below that, I've got the differences and some of the Transact SQL supported and all the rest. You should be aware that your data that you have inside SQL Server 2008, and matter of fact, even 5 and higher, other than certain data types, just the CLR ones, is completely compatible, no difference binarily from what we run in SQL Azure. Same code base in both places. So it's not like we wrote another version of SQL Server for SQL Azure. Another question that often comes up is, what version is SQL Azure? And the answer is that it's version now. What that means is that we're always updating SQL Azure. We update it about 3 times a year, and we have notifications where we let you know what those things are so that you can test your applications and so on. But rather than waiting 3 years between cycles, it's updated constantly. We work very carefully to make sure we don't break anything, and we do. There's a full series there in these links that talks about how you handle the application lifecycle management for Azure. So again, for certain use cases, and I've got the use cases listed there as well in that link, for certain use cases, Azure makes perfect sense. As Roger pointed out, it's not for everything. You wouldn't expect to throw a database on any web server, whether it's Microsoft or anyone else, or even hosted somewhere else, and use very huge workloads across the wire. You always want to think about where the code lives and the processing. The more processing you can put closer to SQL Azure, the better. We do support Windows Azure applications hitting SQL Azure databases, and in fact, you don't even pay for the traffic and the data exchange between those two paradigms. So if you are writing a Windows Azure-based application, a web-facing application, you can use SQL Azure as your relational database management store fairly inexpensively and very quickly because they live in the same backbones. So that's my spiel there on SQL Azure. There's lots more to learn. There's a lot of videos and so on, as I mentioned, and resources at that link. And at this point, I'm going to turn it back over to the Scalability experts, folks, and I appreciate your time today.
Okay, thanks, Woody. Buck. I'm going to first go over a real quick. These are just some of the things that I think you should consider when you're looking at the cloud and databases in the cloud and those kinds of things. And I won't take the time to go over every one of them. These are in the white paper that you're going to get when you get done, so you can dig deeper into some. But there are a few of them I think that are worth talking about. The first one is that. You know, there's always a lot of talk about DBAs being eliminated by, putting your databases in the cloud and all that kind of stuff. And in actuality, that's probably not ever true, because in essence, what it does what I've seen it do is it allows DBAs to concentrate on the stuff that they should have been concentrating on all along, which is, the careful design of the logical database and, tables and indexes and all that kind of stuff that you want to do to make sure that you have, highly efficient applications. What then they don't have to worry about, how do you set up your SAN and how do you move data around and where's your transaction log located and is it getting full and all those kinds of things. Then secondly, number two, I think is probably one of the key advantages of either a public or a private cloud, and that is self-provisioning. It kind of really changes the whole paradigm if application users, not application users, but application owners and testers and developers can easily create a fully functional database on their own in a few seconds and don't have to go to IT and go through all the jump through all the hoops that are necessary to get a full database created. Then let's skip to number 4. And this Buck already talked about this before. Public cloud databases perform best if the database and application are in the same data center. So again, as we talked about, there are a lot of scenarios where you have a local application talking to SQL Azure in the cloud. That works unless you've got a very, very heavy, an OLTP type application that has a lot of usage. And in that case, you're much better off if you're both your database and your application are running in the same data center in the cloud. So again, if SQL Azure database works really, really well if your application is written in Windows Azure. Skipping then to number 6 again. Private clouds are more expensive to create and maintain than public clouds, but provide more control and reduce some of the network and security issues that are done. So it's a decision you have to make. A lot of people are nervous about moving some of their applications to public cloud. So the private cloud might be a good interim solution that you say, well, let's take advantage of some of the cloud infrastructure, the flexibility and all that kind of stuff that we get from the cloud, but let's run it on our own servers until we're confident that the public cloud will handle all our load. And I guess probably the last one is probably the most important one is that it's probably you will probably fairly uncommon to see an enterprise that employs just public cloud or just private cloud. When enterprises move into the cloud, I think what most of them do that we've run into will look at their applications and the ones that are a good fit for the public cloud. And Buck and I both talked about this. Those will be deployed into the public cloud, and there are some of the ones that because they have highly confidential data, or for other reasons you don't feel right about putting them in a public cloud, well, then you can implement them in a private cloud. You get some of the advantages of cloud, not all the advantages of a cloud, in a private cloud setting. So, assuming you want to get started, here's a couple things you can look at. Number one, Azure has what they call a discovery pack program, where for a fixed price you can go in and try out Azure. This is not just a quick demo kind of a thing. This is a full-fledged Azure application that will run a decent-sized application up in Azure using SQL Azure and Azure. And again, talk to your Microsoft representative or talk to us to get that. You get more information on that. There's also, Scalability offers what we call an Azure Cloud Assessment. you have a set of applications and you're wondering, well, will these work in a cloud? Are these good candidates for cloud implementation? We'll come out and spend a day with you talking about your applications and help you work through, are these good applications, good opportunities for cloud implementation, or should we keep them on either keep them on your current infrastructure or possibly look at a private cloud infrastructure also. Scalability Experts offers a full set of cloud services here. Won't go through all of these, but again, at the top, we talked about the cloud readiness assessment. We've got a couple different architectural design sessions to help you to design a cloud implementation of your application, whether it's a new application you're thinking about writing or a current application you're looking at moving to the cloud. We'll spend some time working with you to do the actual migration to the cloud and various other things there. So again, if you're interested in any of those things, get in touch with Scalability Experts. And if you can't find the right person, Scalability Experts, then send it to me and I'll route that to the correct person to talk to. So now we're at the point where if any of you have any questions that haven't been covered yet, we'd be more than happy to take them. So please enter them into the Q&A manager as you find up in your menu bar, and we'll go from there. Thanks. Oh, and while we're doing that, let me put up the last slide because this has email addresses if you want to copy those down. Let's see. I don't see any questions. We'll give this another couple of minutes, but in the meantime, if you notice under Buck, there's that tiny URL address is the one that he showed before in case you didn't get time to copy that down. This will do that. And then again, we will, shortly after this, we'll send out to the list of attendees the slides that you're looking at, pointer to the recording of the webcast, and also a white paper that talks about some of the same kind of things that we talk about here in terms of cloud implementations. So you should be receiving those in a week or so. So if you missed anything that you want to remember, you should be getting a copy of these slides in a little while. Okay. Well, it looks like we're not going to get questions. So
sounds good. Hey, if you do have any, this is Buck, feel free just to pop us an email, as Roger mentioned, and we're happy to field those as we go.
Okay, thanks. So thanks a lot for your time. I'll turn this back over to John so he can close this up for us. Thank you.
All right, thank you so much. Really appreciate the effort you guys put in today. This concludes our webinar. If you have any questions, as they stated, please feel free to email Buck or Roger at the addresses listed on that last slide. And again, in the next couple of days, you'll be receiving an email from me, John Midbo, here at Scalability Experts, with some other relevant collateral to this webinar. If you have any questions, you can't find their email address, anything like that happens, just respond to the email I'll be sending, and I'll be working very hard to make sure you guys get the appropriate responses and all the information you need. Again, thank you guys. You did a great job, and hopefully we'll see you guys in the upcoming webinar. Thanks so much.
See you guys later. Bye.